Hey, welcome to this lesson. In this video, we're going to take a look at forces. So here is the topic map. So we're going to start with introduction to forces, then we'll move on to resultant force. Then when we take a look at resultant force, we're going to take a look at Newton's laws. And this is where this video is going to end. In the next video, which is part 2 of forces, we're going to take a look at special types of forces. There are two special types of forces that we're going to study. And also, we're going to study springs. Let's get started. So what is force? Force is just a pull or a push on an object. If you pull something, it means you have applied a force, and if you push something, it means you have applied a force. The unit of force is newtons. If you remember, the unit of weight is also newtons, meaning that weight is also a type of force. Force is a vector, just like weight, which is a type of force. And weight is a type of force, as I've been saying. So force can be measured by spring balance, just like weight. It is also measured using a spring balance. Then next, we're going to take a look at effect of force. So when force is applied at an object, what happens? If someone punches you, it means they have applied force on your face. So what happens? What can happen to your face or to you? There are two things that can happen. The first is force can change the size or shape of a body. So your face can have its shape or size changed. So that's one effect of force. It can change the size or shape of a body. Second, force can change the motion of a body. So if force is applied to an object, the object can be moved. So if someone punches you, your face can be moved. So there are two effects of force. One, it changes the size or shape of a body. Two, it changes the motion of a body. So next we're going to learn how to describe force. Remember, force is a vector quantity, and here is where you're going to appreciate the meaning of vector quantities. Maybe here onwards, we are going to appreciate the meaning of a vector quantity. So a vector quantity has both magnitude and direction. So it has size and it has direction. For example, these two forces here, they are different here. Even if this was, let's say if this was 8 newtons, this is different from here. Why? Because despite them having same magnitudes or same size, assuming this was 8 newtons, they are pointing in different directions. So they are different forces because they have different directions. So unlike scalars when you are given 8 kg and 8 kg, it means they are the same. But forces, being a vector, they are different because they are pointing in different directions. So this 1 Newton is pointing to the left and this 8 Newton is pointing to the right. So if you have been asked to describe this force, you don't say 1 Newton, you say 1 Newton to the left, or just 1 Newton left, and this other one is 8 Newton right. Mathematically, instead of using left and right for calculation's sake, we can just assign signs. We can say this side, which is right, is going to be positive. So any force that is going to the right, we're going to give it a positive value, and any force that is going to the left, we're going to give it a negative value. So in such a case, the 1 Newton left is going to become negative 1 Newton, and the 8 Newton right is going to become positive 8 Newton. But when you do this kind of assignment, you have to let the other person who is going to read your work or is going to use what you have calculated to know that left was being taken as negative and right was being taken as positive. So somewhere you have to state that where left is negative and right is positive. So always after the calculation, at the end or maybe at the beginning, you have to state that left is going to be negative and right is going to be positive for you to apply this. So in summary, you can describe force by directions: left, right, upwards, downwards. But for the sake of calculations, you can just assign signs to the numbers or to the directions. So for example, you are dealing with up and down. You can say let up be positive and let down be negative. And whatever number or whatever force is going upwards, you're going to give it a positive value, and whatever force goes downwards, you're going to give it a negative value. So here's another example. We have 10 newtons here and 3 newtons here. This is going upwards, this is going downwards. So how do you describe these forces? So of course you can use 10 newtons upwards and 3 newtons downwards, but like I said, you can just assign symbols. You can say up should be positive and down should be negative, and this 10 newtons is going to become positive 10 newtons and 3 newtons is going to become negative 3 newtons, and you have to state at the end where up is positive and down is minus. Then we move on to resultant force. Resultant force, which just from the word means a force that results from other forces, or in short, it can be defined as actually the description: if two forces or more act on an object, there is a force which results because of them. It is called a resultant force. So this is a force that results from different forces acting on the same object. So let's say we've got this object here with two forces acting on it. There's this force and this force. So these forces are in a way adding up or cancelling such that there will be a resultant force. Imagine a situation where a certain force is pushing this object this direction and this force is pushing this direction. If this force is bigger than this, then this object is going to move this direction despite this also pushing it in the opposite direction. So let's say this is 5 newtons and this is 8 newtons. Where do you expect this object to go? Of course, it will go to the right. Why? Because the force here is greater. So but the speed at which it will go is going to be different if there was no 5 newton here. If there was no 5 newton, it will move fast if it is pulled with 8 newtons. But if there's 5 newton here, then it's going to be different. So the force that is going to contribute to the motion is the resultant force, which is just the difference between these two forces. So to get the force, what you do is, to get the resultant force, what you do is you can just draw if you can, but the length of the arrows should be proportional to the force or the magnitude of the force, and their direction should be the same as the force. So this arrow on top is 8 newtons because it's a little bit longer than this one. So I've just estimated that this is 8 newtons, and this other one it's going in the opposite direction, which is the left or the negative, and it's 5 newtons. So the resultant force is how much force should be added here for this force to reach here. So this is 5 newtons. We need about 3 newtons for it to reach here, so that this is equal to this. So this 3 newtons force, which is here, is the resultant. And the way to draw it, you start from where the first force starts and you end it where the second force ends. So the first force starts here, so you draw a straight line. Then the second force ends here, so you draw a straight line. Then you draw an arrow from where the first force starts to where the second force ends. This is the resultant force. So this shows that this object is going to go this direction because the resultant force is pointing to the right, and the magnitude of the resultant force is 3 newtons. This direction is right. So another way in which you can tackle these things, if you don't want to go through this whatever here, what you do is you just assign signs. So we can say adding the two forces, we can add the two forces, then we can take right to be positive and left to be negative. So we can add the two forces so that we find the resultant, and we take right to be positive and left to be negative. When we do that, this one is going to be 8 newtons and this one is going to be negative 5 newtons, and I'm going to have this 8 newtons minus 5 newtons is 3 newtons. So this is the magnitude. But how do you tell the direction? The sign, it's positive. We have said positive is right, meaning that the resultant force is 3 newtons going to the right because it's positive. If it was negative, then it could have been 3 newtons going to the left. So here is another scenario here. So we have 8 newtons and we have 8 newtons here. What is the resultant force? So again, you draw a line equivalent to 8 newtons, you just estimate. Then if you have a rule, you can even use 8 centimeters to represent 8 newtons. So this is 8 newtons. Then you can also draw another one going to the left, which represents this 8 newtons. And they are equal because the forces are equal. And the resultant force, like how much force are you supposed to add to this one to get this? It's 0. Or even if you draw the lines, where the first force starts, it's here, and where the second force ends is here. So there will be nothing here. So the resultant force is 0, provided that this is 8 newtons and this is 8 newtons. the resultant is 0 newtons. And using our mathematics here, we just say, okay, right is positive and left is negative, so right is positive 8 and left is negative 8. Putting this together, we're going to get 0 newtons. What about these? These are called compound forces. If two forces are pushing the object in the same direction but acting at different points, they are called compound forces. But don't worry about that. No one is going to ask you what a compound force is. So let's say this is 8 newtons, this is 1 newton, this is 3 newtons, and this is 6 newtons. What is the resultant? So again, just draw the first line for this 6 newton, and another short line for this 3 newton, which are these two. Then again for these two, you do the same. So where the last force you drew ends, that's where you start. So just go down and you start. You draw this is 6 and this is 3. So actually on top, so I've drawn the 1 newton and the 8 newton. So the length here it's 9 newtons, and the length on top it's also 9 newtons, meaning that the resultant is also 0. And using our mathematics, taking right positive and left negative, so I have 6 newtons going right, plus 3 newtons going right, 8 newtons going left, and 1 newton going left. And when we add, we're going to get 0 newton. So one thing you should know about a resultant force being 0, it means 0 resultant force means the forces cancel each other out, or they are balanced. So when you have 0 resultant force, it means the forces are equal, or they cancel out each other, or they are balanced. What that means is the object won't move because it won't be feeling like there is any force outside, because the force on one side cancels with the force on the other side. So there is no any force that is going to make the object move. So that's what you should know. Finally, we'll take a look at Newton's laws of motion. So there was this man in England who came up with 3 laws that describe mechanics of things, how things move, how things behave, and the likes. So the first motion is simple. It says if all the forces are balanced on a body, meaning that there's no resultant force, then this is true. An object will be at rest and it will continue to stay at rest. An object, if it is moving, will keep moving at a constant speed in a straight line. So in a nutshell, an object that is at rest, it will continue being at rest unless an external force acts on it, unless someone touches it or pushes it. Then if something is moving, it will continue moving, to never stop until something else pushes it to stop. So what this says is, if you kick a ball, that ball will continue to be moving, to never stop, unless there is a force that's going to act to make it stop. A force called friction force that we're going to start in the next video. So that's what Newton's first law states. Something that is at rest will continue being at rest. Something that is moving will continue move if there is no external force acting on it. If there's nothing to stop it, and that one which is at rest, if there's nothing to make it move. Newton's first law of motion, simple, nothing academic. We all know you can't just put a phone and expect it to move. Someone has to push it. So that's Newton's first law of motion. So the most important thing that we get from Newton's first law of motion is something called inertia. So the property of a body that resists a change to its motion is called inertia. A good understanding or appreciation of inertia is when you are in a car, or let's say in a bus, and it's moving at a certain speed. What happens if that car stops? You move forward. Why? Because as the car was moving, you were moving, and when you stop suddenly, you kept on moving. So your body, the property of your body that resists it to stop moving because it was moving, it's called inertia. So whenever this happens, you are in a vehicle, you are in a car, then it's moving, then it stops, then you act as if you want to continue moving. Remember, inertia is the property of your body that resists the change in its motion. So the car is saying stop, but your body says no, I'm still moving. So that is inertia. So inertia depends on the mass of an object. If something has a high resistance to change of motion, meaning a high mass, it is said to have high inertia. So the higher the mass, the greater the inertia. The second law of motion, Unbalanced forces acting on a body produce acceleration in the direction of the force. Okay, so if you have two or more forces and the resultant is not zero, mean that they are not balanced, mean that they are unbalanced, and that implies that there is a resultant force that is pushing that object in a certain direction. So if the forces are unbalanced, then that object is going to be moved, and if there is movement, it means there is acceleration. So unbalanced forces produces acceleration in the direction of the force. So if the resultant force is to the right, it means the board will move to the right. This is not complicated. We all know this. If you push the board to the right, it will move to the right. So that pushing force you're adding is the unbalanced force. So that's what Newton's second law of motion states. So mathematically, Newton came up with a formula, and he said this acceleration that is going to be produced is directly proportional to the force and inversely proportional to the mass of the body. Direct proportional means if you increase acceleration, the force also increases, or if you increase the force, the acceleration increases. You push something with too much force, that object is going to move fast, meaning that there is an increased acceleration. Also, this acceleration is inversely proportional to the mass of the body. Inversely proportional means if the body is huge, then the acceleration is going to be low. So even if you push an object which is big, it's not going to accelerate fast as compared to a smaller object. Simple. Sit down and think about this, and you're going to see this is simple. These are the things that you see in everyday life. So mathematically, this can be written as force is equal to ma. This statement can be written as force is equal to ma. F is force, m is mass, a is acceleration. F is force in newtons, m is mass in kgs, not grams but kgs. Always keep that in mind. M is mass in kgs, and a is acceleration. So acceleration, of course, is meters per second squared. So this is the formula that you use to calculate the amount of force, knowing that you know given that you know the mass of the body and its acceleration. Here are some examples. A force moves a ball of mass 5 kg and it accelerates at 2 meters per second squared. What is the force acting? What is the value of the force, or what is the magnitude of this force? So the formula for force is mass times acceleration. Mass is 5 kg, acceleration is 2 meters per second squared. So when you plug in, you are going to have, I made the mistake, sorry, written 350 kgs instead of 5 kgs. So normally, okay, so let's do this. Let's assume this was 350 kg. There is a typo, a mistake. So if this mass is 350 kg and acceleration is 2 meters per second, so we're going to get 700 newtons. So a force moves a ball of mass 350 kg and it accelerates at 2 meters per second squared. Find the value of the force that is making this motion. So force is equal to mass times acceleration. Force is equal to 350 kg times 2 meters per second squared, and force is equal to 700 newtons. Another example, a force of 350 newtons acts on an object of mass 10 kg. Find the acceleration. So again, we use the formula force is equal to mass times acceleration. We've been given the force and the mass. The job is to find the acceleration. So force is 350 newtons. Mass, again, another mistake. Sorry, I was not stating my masses correctly. So force is 350 newtons and mass here is 350 kg. So 350 newtons equals 350 kg times acceleration. So you can divide both sides by 350 kg so that you make acceleration subject. When you do that, you're going to have this, and you're going to end up with 1 meters per second squared being the value of acceleration. Newton's third and final law, very simple but very interesting. It says for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. What does it mean? It means if there is a body here, and if you push this body with a force of 20 newtons, there will be a force acting here opposing your push, and it will have the same value but acting in the opposite direction, like so. So if you are pushing with 20 newtons, the opposite and equal force is going to be acting at the same point. So remember, opposite and equal. So if this is 20 newtons, this is also going to be 20 newtons but acting in the opposite direction. If this is acting towards the right, this is going to act towards the left. Mathematically, you can say this is positive 20 newtons and this is going to be negative 20 newtons. So if you have been given a question where they ask you to find the reacting force and you have been given the acting force, just get the value of the acting force and negate it or put a negative to show that it is going to act in the opposite direction. This marks the end of this topic. Hope you have enjoyed and I love this topic. Otherwise, happy solving.